the first derivative test. So we've been talking about like what makes a particle go left or right, or stop, when the velocity or f prime is greater than 0, it's moving to the right or forward. When it's less than 0, it's moving left. So now we can figure out what the function is doing. Is it increasing or decreasing on a certain interval? And we can do that by doing the increasing or decreasing test. So we have to first make sure that f is continuous on the closed interval and that it's differentiable on the open interval. If that is true, then when the derivative is greater than 0, we can say that the function is increasing. If the derivative is less than 0, according to our sign chart, when we do our sign chart, find our zeros, we can figure out our pluses and minuses, then we can state that f is decreasing. When you state your reasons, those are your reasons. When it says justify your answer, if you want to justify that your interval is increasing, it would be because f prime is greater than 0. The justification for f prime is f is decreasing is f prime is less than 0. That's it. You don't want to be too wordy and work yourself out of an answer. Okay, so if you write too much and you write something right, but then you go and write something incorrect, then you go from getting that point to that point going away. So don't be too wordy on that. Just f prime greater than 0, f prime less than 0. Then we also have the first derivative test for local extrema. Yesterday we did the candidates test for the absolute max and mins. The first derivative test is going to be for the local extrema, the relative. Okay, so when you're talking about local or relative, you have to say local or relative. You can't just say max or min. Because if you just say max or min, that's going to be an absolute. So max, min, absolute max or min, global max and min, those all mean the same. If you're talking about a relative or local, you have to say relative or local when you're talking about it. So again, okay, it's a continuous function and it's differentiable on every point, okay? But then it says except. So except possibly a value, c is an x value, itself. So what that's kind of talking about right there is this right here. So this little corner cusp looking thing right here, in this particular graph, it is an absolute. It is the absolute highest point. But if that cusp was not the highest point, it could be a relative max as well. Because that would be except at c. So at a specific x value, if that corner or cusp, because that's where that is not differentiable, that could be a relative max or min as well. Remember, the endpoints can only be absolutes. And in order to have a max or min, you have to have a change of the signs. The signs have to change. And by signs, I'm talking about the signs of the slope of the tangent line. So if we look at this graph right here, notice the slope of the tangent line is, then it goes to 0 and it's still positive. The sign did not change. So that is this third situation right here. It went from positive to 0 to positive. It did not go from positive to negative. So there's no max or min right there. That's why there is no extrema at that point. But here, the slope went from positive to 0 to negative. So just think about it. It's going from positive, that's going up, to negative is going down. That's going to create a max, whether we have the graph or not, because we're not going to have a graph a lot of times. We're going to have our sign chart, and our sign chart is going to tell us what is happening to f prime along the way. You go from a negative slope of the tangent line to a positive slope of the tangent line. That's what creates a minimum. Okay, so remember, relative or local extrema have to happen in the interval, in the inside. They cannot be an endpoint. All right, so this first example, we want to know where f is increasing and decreasing. So where f is increasing, it's going to be where f prime is greater than 0. Where f is decreasing, that's going to be where f prime is less than 0. So we got to find where it is 0, and then we can figure out where it's positive and negative. Now, with a problem like this, you also always have to take into account your domains, because this problem is a fraction. Ratios, fractions, you can't have a 0 in the denominator. So when we do our sign chart in a minute, we have to also remember that x cannot be 1/2 because that's going to make that particular function undefined. We're going to graph this function also because there are a lot of things that we will do later on that a graph is sufficient for you to get the information out of. This one we don't have to, but I'm just going to show you to remind you about long division, asymptotes, slant asymptotes, stuff like that, so you can see what is actually happening. If this was, let's say there was a radical involved, we have to remember a radical, as far as domain goes, is greater than or equal to 0. If it was a log or natural log and you had an argument, you have to remember the argument must be greater than 0. So when you're talking about your domains, you have to remember whatever's given. If it was just x squared, everything works. Okay, that's continuous, it goes on and on forever, negative infinity to infinity. But we have a denominator can't be 0, an argument must be greater than 0, and number under the radical must be greater than or equal to 0. Those are the three kind of situations that could happen. All right, so first I'm going to find the derivative. Well, first I'm going to graph it. So if we were to graph this function, okay, just to kind of see what happens. Again, this particular one, you don't have to graph it to find that stuff out, but it could come up where you need to graph it. I just want to remind you what to do. So we have an asymptote at 1/2. The reason we know that's an asymptote, because that's what makes the denominator 0. Well, it's an asymptote. If we could factor and remove it, that's what makes it a whole. So whole versus asymptote. Whole is removable, means it factors and it cancels. An asymptote is non-removable. Then our numerator exponent is bigger by 1, so what that means is there's a slant asymptote. There's no horizontal asymptote, but it's a slant asymptote. So again, just a reminder about long division, because that pops up every once in a while also. X squared divided by 2x minus 1. So I like putting the degrees all the way out to the constant. So 2x times what is x squared? That's going to be 1/2 x. That gives me 1x minus 1/2, x squared minus 1/2 x. Change the signs. 1/2 x plus 0. 2x times what is 1/2? Plus 1/4. And remember, in long division, that's all you have to do. Once you get your equation of the line, you have your slant asymptote. So it's pretty flat, and it goes through 1/4, so that's what our slant asymptote looks like. And then if we want to find our zeros, okay, if we want to find our y-intercept. So if we want to find our y value, y equals 0 over -1. So if I plug in 0, I get 0. So I don't really have to find my y-intercept and my x-intercept, because if the x1 is 0, the other one's 0. So there's that side of the graph. And then if I picked, let's say I picked, I don't know, 3. 9 over 5 is going to be somewhere up here. So there's that part of the graph. You pick whatever numbers you want. You could have picked 1, picked 1 squared over 2 minus 1. We would have gotten 1. And since this was up 1 over 2, we knew it was up here. Again, just to know what side of this slant asymptote that happens. So again, this particular problem, we didn't have to do that, but there are going to be some where you do, and you can see that according to this graph, we're going to have a relative max. We're going to have a relative min, and we're going to be able to figure out where those are without putting in the calculator and finding your max and a min. So we do that by finding the derivative. So f prime of x equals, this is the quotient. Don't forget about the denominator in the quotient, forgetting that g squared in the denominator. So we have 2x times 2x minus 1 minus, that parentheses sometimes is necessary, sometimes isn't. It just depends if there's more than one term. We put the parentheses just to be safe. X squared times 2 that time, doesn't matter, over 2x minus 1 squared. So we distribute that in. So f prime of x, we have a 4x squared minus 2x squared. That gives 2x squared, and a 2x times negative 1 minus 2x, all over 2x minus 1 squared. So again, we're finding increasing and decreasing, so we need to know when f prime is positive or negative, and that'll tell us where f is increasing or decreasing. So we need to first find where it's 0, and remember that undefined needs to be involved also. So we're looking forever. There's no closed interval. Looking at that function, just looking at our picture, it goes to the left forever, it goes to the right forever, so positive to negative infinity. This, we already established that at 1/2, okay, it's undefined, which is not a 0, it's undefined right there. But this, setting it equal to 0, will give us our zeros. So I can factor out a 2x, which leaves me with x minus 1. So my zeros are 0 and 1. What I do is I put like a little dashed line right there at 1/2. So I know when I write my intervals in a minute, I don't include that. If you don't put that on your graph, then you're probably going to forget about that 1/2, and that 1/2 can't be part of your answer because the function does not exist at 1/2. There's an asymptote there. All right, so these are factors. Remember, to our sign chart, we're plugging in factors. So at 0, any number I pick that's less than 0 is going to be negative. Any number greater than is going to be positive. So at 0, anything to the left is going to be negative. Bless you. I don't put the positives because the positives don't change anything. And then x minus 1, if I plug in 1, it's 0, but if I plug in anything less than 1, it's negative. Anything greater than 1 is positive. So here's 1. Less than 1 is negative. Anything greater than 1 is positive, so this section's positive, negative, negative, and positive. You can do your two little parentheses. You can plug it into the 2x squared minus 2x. You can pick negative 7. You can pick 0.4. You can pick 0.7. You can pick 3. Well, I already did that. I know 0, it's 1/2. Is there any, and check the denominator, because what happens what? When I plug a number in here, it's squared, so everything's positive, so positive doesn't do anything to it. So I don't need to include that in my plus and minuses. Then that would affect it. Well, I already did that, but I have to find my positive and negatives with that denominator. If that squared wasn't there, then yes, that would affect my sign chart. Yep. This one? This one? So if I plug in, let's pick a number. So let's pick negative 6. If I plug in negative 6 right here, I get a negative. If I plug in negative 6 right here, I get a negative. So when I plug a negative 6 in here, that gives me a positive number. Yeah, sure. It's just, all we care about is positive and negative. So instead of it's a lot easier for me to see, okay, I'm going to get a negative, I'm going to get a negative, as far as that goes. Or because these are just in regular x's first and then y, any negative I plug in here, I'm going to get a negative. Any negative smaller than 1 I plug in here, I'm going to get a negative. And so that's how I ended up with those signs. Okay? But how you come up with those, like plugging into the original or the factored form, those are the same as long as you factored it correctly. It doesn't matter which one you do. So now I'm ready to answer the question. I think I need to answer the question. Increasing and decreasing. When f prime is greater than 0, f is increasing. f prime is less than 0, f is decreasing. And that was the question. Find the intervals where f is increasing or decreasing. Okay, so f is increasing wherever it's positive, wherever the derivative, that's our derivative graph, and sometimes you'll have derivatives and second derivative graphs, so if you label them, it's going to be easier to tell them apart also. So f is increasing from negative infinity to 0 and 1 to infinity. You can say and, you can put them next to each other, you can put the u, you don't have to do any of them. Justify your answer because f prime is greater than 0. Don't say it. Don't say it is increasing because it is greater than 0. Don't ever say it. AP graders see it, they're going to count it wrong and move on. We don't know what it is. F is increasing. We're talking about two different things, f and f prime, so we need to keep them separated. F is decreasing. And we can say on the interval. 0 to 1/2 and 1/2 to 1. We have to exclude the 1/2 because 1/2 makes f undefined. So that's why we had that little dash line. It didn't make it 0, it made it undefined, so it can't be part of our interval because f prime is less than 0. If you want to say f prime is negative, you want to write out the words, you want to use the word negative, you want to use a negative sign, any of those will work. But don't write too much. Talk yourself out of the answer. Then it says, identify the points. So it wants x and y values. Identify the points that are relative max and mins. So again, we just look at this. The slope of the tangent line is positive. So the slope of the tangent line is positive, then it's negative. So if it's positive, then it's negative. That's going to create a maximum. That's the only place it goes from positive to negative. So we have a relative max at 0. We want the point, so we got to figure out what the y value is, which, because we graphed it, we already know what happened. Then 0, we got 0. 0 divided by negative 1, we already got our 0. So relative max at 0, 0, and again it asks for a point, so we want to be sure and put the point because f prime, not it, changes from positive to negative. And you can use plus for positive and minus for negative. Okay, that is acceptable. Then negative, so there's no sign change right here. Okay, no sign change right there. Negative to positive creates a minimum. So we have a relative minimum that's at 1. We got to figure out what value goes with that because again it wants the point. Because f prime changes from negative to positive. You want to use the plus and the minus. And so, again, we're talking about f. Where's the relative max and min on f? So that's why we plug this 1 into f. So 1 squared over 2 minus 1, 1. So 1, 1. Now, is it always 0, 0, 1, 1, 2, 2, 3, 3? Absolutely not. Okay, that is not a thing. Do not just assume that it's the same number. And so there's all of your parts. So the justifications are the same no matter what problem. Anytime it asks for is it increasing or decreasing, justification for increasing. Justification for a relative max. Justification for a relative min. No matter what it is, those are your justifications. Explain why, that is what you do. All right. Next one, same question. Intervals of increase or decrease and the local extrema, but we have trig. So when we look at this, there's nothing to really do to it, but it does give us an interval. So we only care about the values from 0 to 2 pi. So when we solve this, that's all we have to worry about. We don't get any further than that. We don't have to come up with an equation. We just have to find it on that interval. So f prime of theta equals derivative of cosine, C word, is negative. So negative 2 sine theta. Derivative of cosine is negative, so minus a negative is plus sine 2 theta times the derivative of the inside, chain rule, times 2. So we have f prime of theta equals negative 2 sine theta plus 2 sine 2 theta. And, I mean, you wouldn't have to use that step to rewrite it. You can if you want. But sine 2 theta isn't something we can evaluate. Okay, we don't have enough information. So we got to go back to pre-cal. The pre-cal friends know this right now. That's the double angle. So negative 2 sine theta plus 2 times 2 sine theta cosine theta. Now all of our angles are just theta. We can't do anything. We can't factor out a sine theta out of a sine 2 theta. That's like saying this is sine 30 and this is sine 60. We can't factor out a 30 degrees. That's not a thing. You can't change the angle. So there's your double angle ID. Now, you can factor something out, a 2 or negative 2, whichever you want. I'm going to take out the negative 2 sine theta. Again, the positive or the negative isn't going to matter. It's going to work itself out in the answer. Whether you take out the negative or not, it's going to work out to be the same. And so that leaves us with 1 minus 2 cosine theta. Again, this was our f prime of theta here, and we want to know when it's 0. If we can find when it's 0, then when it's 0, one side's going to be positive and one side's going to be negative. So we would say 0 equals negative 2 sine theta, and 0 equals 1 minus 2 cosine theta. Do you have a question? If you need to go one step further, well, I am going to go one step further, 2 steps further, so I'm going to divide by negative 2. So 0 equals sine theta. If you need to write inverse sine of 0 equals theta, you can. Over here, subtract 1, divide by negative 2. 1/2 equals cosine theta. Again, what I just said, if you want to write inverse sine of 0 equals theta, you can solve for theta. Inverse cosine of 1/2 equals theta, you can do that. It's not necessary. And so here, we're only looking for values between 0 and 2 pi because it gave us that domain restriction at the beginning. So just like yesterday, same numbers, 2 pi, 1/2, pi over 3, 5 pi over 3. We did that twice yesterday, so we should at least remember that. Those are the same. So those are the 5 values that are going to go on our sine chart. And remember, we're not going to go past 0 and 2 pi because that was given there as a restriction at the beginning. That's all we're looking for. All right, so we have 0, write that in order, okay, from smallest to largest. That is important here. Pi over 3, pi, 5 pi over 3, and 2 pi. Now, if you're really good at trig, you might be able to come up with those plus and minuses in your head. If you're not, write things down. And it might not be just an easy thing to come up with in your head. You might have, and some of them might be easy, some of them might be hard. But your first thing is you got to pick a angle that's in between 0 and pi over 3. So I would pick pi over 4. And again, this is our F prime sign chart. F prime is going to tell us about F, increasing, decreasing, relative max and mins. We can use our factors, or we can use our full F prime equation. Either one is fine. Okay, this was F prime, this was F prime, these two are F prime, you can do whatever you want. I'm going to use those factored, that factored version right there. So if I do pi over 4, that's negative 2 times sine of pi over 4. You can do this in your head. You don't have to write this down. I'm just writing it down so you can see what I'm doing. And then 1 minus 2. So we have negative 2 times root 2 over 2. And 1 minus 2 times root 2 over 2. So this factor, all we care about is positive or negative. Doesn't matter what the value is. We're just looking for a line chart, pluses and minuses. This is going to be 1 minus root 2 is bigger than 1. Even if I don't know what root 2 is, I know that root 1 is 1. So root 2 has to be bigger than 1. So 1 minus a number bigger than 1 is going to give me a negative. So at pi over 4, right here, that section's positive. Because the two factors gave me negative times negative. These were my two factors of my F prime chart. All right, between pi over 3 and pi, I would use pi over 2. That's an easy one. Might be able to do that in your head. Okay, I'm going to write it down. Negative 2 sine of pi over 2, sine of pi over 2, top, at the top that's 1. And then I have 1 minus 2 times cosine of pi over 2, that's 0. So a negative times that section is negative. You can pick any number you want in between pi over 3 and pi. But pi over 2, if it's a quadrantal, I would always pick a quadrantal if you can, because the only options for quadrantals are positive 1, negative 1, or 0. Oh, what's a quadrantal? Are you kidding? Quadrantal. I believe it. Yeah, I can bring up the pre-cal notes, the pre-cal quiz, the pre-cal test. Everybody missed that on pre-cal everything last year. It was typed for you on your pre-cal notes. Well, it's a reminder, not a new concept, what a quadrantal is. Three pi over 2 is a quadrantal because it lies on an x or y axis. And an x or y axis, again, if it lies on an x or y axis, that's the thing to evaluate, because your only choices are 1, 0, 1, negative 1, 0, 0, negative 1, or 1, 0. It's just easier to evaluate than having roots and stuff. So, 3 pi over 2. Negative 2 times sine of 3 pi over 2, that gives me a positive. Then I have 2 times 0, positive times positive. This section's positive. Do not just assume it goes plus minus plus minus. Maybe it does, maybe it doesn't, but do not assume that ever. And then I would probably pick 7 pi over 4. Any number between 5 pi over 3. You can pick 11 pi over 6. I would pick either 7 or 11 pi over 6. I don't know how you figure out those others without a calculator. 2 times sine of 7 pi over 4, that's going to be negative 2 times a negative. So that's a positive. And then you have 1 minus 2 times root 2 over 2. So you have a plus and a minus. So that section's negative. So it does go plus minus, but again, do not assume that is always the case. The one we just did wasn't plus minus, plus minus. It was plus minus minus plus. So do not assume that happens. Now we can answer the question. Same question as before. F is increasing. Don't say it. Name what is increasing. F is increasing 0 to pi over 3, pi to 5 pi over 3, because F prime greater than 0. Always the reason for increasing. F is decreasing from pi over 3 to pi and 5 pi over 3 to 2 pi, because F prime less than 0. The derivative is less than 0. The derivative is negative. Okay, don't include an equal sign right there because then that's wrong. Less than 0 or negative. And then we have our max and min question. So, notice we get positive to negative here and from positive to negative here. There's two places positive to negative. So, we will have a relative max at pi over 3 something. We'll find that value in a second. And 5 pi over 3 something, because F prime from positive to negative. Now, we're talking about relative max of the function. So we have to go back to the function and plug that in. And the function was 2 cosine. So 2 cosine of pi over 3 minus cosine of 2 theta. Theta is pi over 3. So 2 times 1/2 minus cosine of 2 pi over 3, 1/2, negative 1/2. So 1 plus 1/2, 3 over 2, or 1.5, 1.5, all of those are the same. And if you think about 5 pi over 3 on our unit circle, okay, over here, pi over 3 and 5 pi over 3, we're only dealing with cosine, and cosine is the exact same thing over there. It's 1/2 here, it's 1/2 here. So, therefore, we have 5 pi over 3, it's going to be 3 over 2. Then, we have a relative min, and that's going to be when it goes from negative to positive. So the derivative is going from negative to positive at pi. So relative min at pi something, because F prime changes from negative to positive. So 2 times cosine of pi minus cosine of 2 pi. Yes. Could be. Is that relative and that relative? They could have, that's relative, they could all be different places. Yeah. Yeah, doesn't make it true. So cosine of pi is negative 1, minus cosine of 2 pi is 1, so negative 2 minus 1, negative